Okay, my name is Sean Walbridge, and I'm a developer on the geoprocessing team. And I'm here with Kevin Butler to talk to you today about spatial data science in ArcGIS, exploring the ecosystem. So this whole talk is up on GitHub. There's PDF available. There's also a pretty in-depth resources section that has many links that you won't be able to see directly in the video. So feel free to follow up with those and check out anything that you see that's interesting. All right, so one of the first questions is, what is data science? There's already a lot of talks in this year's Dev Summit covering this and giving you a lot of depth and a better sense of data science, and really specifically spatial data science. We still need to start out a little bit with terms. One model of this is it's just an evolution of the scientific computing paradigm. This combination of a variety of different areas and disciplines, some of them are domain specific, that are necessary to effectively bring to bear answers on scientific problems. So for ArcGIS itself, ArcGIS is a system of record. It really allows you to combine data and analysis from lots of different fields, right? You could be working with people who are archaeologists, you could be working with, fluid dynamic physicists, you could be working with all kinds of different people who have domain knowledge, and the GIS kind of gives you a really great way of putting that all together. One thing is though is that any system, ArcGIS included, can't do everything, right? We provide over 1,600 geoprocessing tools. We do a lot to give you as many rich, fully fleshed out tools as we can, but we also recognize that it's necessary sometimes to enable integration with other environments. That might be particular software packages, it might be other programming languages, so that you can extend the platform in the directions that make sense for your needs. So in one way, you can kind of think of ArcGIS as just being an ecosystem that lends itself well to the kinds of work that spatial data scientists do today without us. But I think that marrying their interests and ours has produced some really interesting results. Okay, so one question is just, what do we ship? What is in Pro? What do I have available to you if you do nothing else? So we have a lot of different pieces that Python in particular is connected to, and we have a Python API for driving our main desktop product and server as well. That's arcpi. There's a lot of integration built into the desktop products to interact with Python effectively. Things like Python add-ins in 10x, Python toolboxes, an interactive window. Obviously, we've added notebooks in Pro, so that's a rich and new experience that gives you a lot of nice ways of interacting with Python. Also, a lot of help with things like debugging, interactive debugging, moving back and forth between a script tool and specific debugging steps in, say, the validation code. That can all happen now directly with Pro. And you also can use, of course, the ArcGIS API for Python. That's included in all of our major distributions of Python. And arcpi is also available in hosted notebooks. So this is kind of what that looks like. If you look across all the different pieces that Python touches, you see lots of penetration in the enterprise tier, lots of product offerings, things like hosted notebooks that are really based around Python, and a lot of extensions also let you directly bind down to Python and use Python for core parts of their analytical workflow, so things like raster analytics and geoanalytics. And on the desktop, it's the primary language people use for automation, for doing their analysis. And that's fortuitous for people trying to do spatial data science, because it also happens to be the primary language people are using to do data science more generally. You also can use it in runtime. If you have a workflow where you need to get access to certain geoprocessing tools through runtime, it's also possible to do it with that. And one of the things that makes this integration work so well for us is our technology partner, Anaconda, who we've put their technology into our software, and that really opens up a lot of doors in terms of being able to make these broader integrations happen. Another way of looking at this is just what have we been doing in the last decade with relation to Python. This chart here is showing you the number of total geoprocessing tools per release year. So getting back to that idea of what do we do? What do we provide out of the box? This is really massive, right? This number has gone up dramatically, and there's lots of different areas that the tools we provide give you new capabilities in, including very rich and robust modern methods for things like spatial statistics. But there's also the what are we doing in terms of giving you new features, and that's what you see just above the data points here is what are the new things, where are they coming in the releases. So we're doing a lot of different things. We also have things that are happening on different time scales. So things like ArcPi, Pro, and the REST API, these are things that are foundational technologies that we build out, and we tend to be very stable and very cautious about how we change them. And the idea there is that you want code in those environments to run, decades later. So we are very careful about when we make any changes to those interfaces. There's other areas like deep learning and the Python API where we want to be able to move fast. And that means that we may have to deprecate things, we may have to make changes to interfaces. And that's partly just to keep up with what's happening more broadly in the ecosystem. There's also things like Conda, which itself is changing quickly, and R. These are tools and environments which are changing a little bit more rapidly, and those are places where you don't necessarily have that same level of stability, but you also are able to take advantage of the most cutting edge things. It's just if you deploy something, it may not necessarily work 6 months down the line. Okay, now I'm going to hand it off to Kevin to show you an example of notebooks in ArcGIS Pro.
Thanks, Sean. For our first demo today, we'd like to show you the power of notebooks in ArcGIS Pro. Here I'll just go to the Insert menu, and you might notice something new in the ribbon for Pro, a new notebook. These are Python notebooks embedded in the ArcGIS Pro interface. Well, we've been talking a lot this morning about data science, and if there's one thing that defines data scientists, it's the fact that they use a wide variety of platforms and interfaces to solve whatever problem is put before them. And so we wanted to make Pro your spatial data science notebook. It's your spatial data science workstation. So this is the ability to include a very common interface that you're already familiar with, notebooks, inside of the ArcGIS Pro applications. Let's look to see how that would work. So I'm just going to do Insert, New Notebook. I'll just call this Test for right now. You can save it. You can see in my catalog view over here that a new notebook was created. I'm going to go ahead and open that notebook. And we're back to a very familiar user interface with Jupyter notebooks, but they're embedded inside of the Pro interface. This should look quite familiar to you with the traditional menus that you would find in any notebook. I'm going to go ahead and import ArcPi. And just so that I can run something, how about arcpi dot, let's see, get install info. And we can see that this functions just like a regular notebook. So that I don't have to do a lot of typing, let me go ahead and show you some existing notebooks that I've already created. Here, I have a markdown cell that tells me what I'm going to do, the fact that notebooks are self-documenting. I like that. And I'm going to go ahead and just run this cell where I'm importing ArcPi, getting some install information, and then setting a GP environment to overwrite processing. And one of the powerful things about notebooks within Pro is that I can quite easily run any geoprocessing tool that I want. Let's take a quick look at some data. Here I have hailstorms in the US for a long period of time, and what I want to do is actually summarize those. So an easy way to do that is to do kernel density. So I'll go ahead and run this kernel density tool. We can see that it is indeed running. I have full control over where my output rasters go. And this will take just a second or two to run. We're looking at probably a couple 100,000 points there in order for kernel density to get through. You might be wondering how I actually got this syntax. I don't have to type all of this into the notebook. One of the benefits of having a notebook embedded in Pro is that I actually ran this tool through my GP interface, and I'm able to actually just go over here from my history once I filled out the GP tool dialog, and I ran it in the traditional Pro interface, and then I can just copy that Python snippet and paste it right here into a cell. And we can see that that tool did indeed run, and it added the output to ArcGIS Pro's table of contents pane there. So that's just a quick demo to show that notebooks are indeed embedded inside of ArcGIS Pro. I can also extend ArcGIS Pro in this environment. I'm going to add a notebook that I've already created. And this is showing the power of pandas. As Sean indicated, we have some built-in libraries in ArcGIS Pro to make your data science processing a little more convenient. Pandas is one of those. I'm going to go ahead and add this notebook in and go ahead and open that notebook. And this is just a workflow that I've worked up in Pandas in order to analyze some airport data, some passenger data from the U.S. Department of Transportation. And it's a full Pandas workflow. And I have the benefit of just seeing it here in ArcGIS Pro and doing that explanation there. So I think you'll see that it's quite easy to use notebooks in ArcGIS Pro. It's the best of both worlds, having your familiar notebook interface embedded inside of the familiar ArcGIS Pro application. So back to you, Sean.
Okay, so what are some of the core Python libraries that we provide? These are things that Esri didn't produce, but they're things that augment your ability to do interesting computation and perform data science operations. Well, SciPy is a big part of this. There's historically been this idea of a SciPy stack, a collection of tooling built around SciPy, and it is about trying to do operations that many different domain scientists have found they need to do. So it brings a lot of pieces of those problems to Python. There's a lot of different pieces of this quote-unquote SciPy stack. Some of them you've probably seen before, things like pandas. But the idea here is that Python's provided this whole ecosystem of tooling to make doing things like data science in Python as effective as possible. And these are all open source communities. You can join them. They often have well-tested, robust code bases. It's really cool to see what's going on in terms of the community side of these projects. So one pretty foundational piece of this stack is Matplotlib. So Matplotlib is a plotting library, and it lets you take Numpy data and do interesting things with it. There's all kinds of plots you can make using Matplotlib. It's been available in our software for many, many years now, and it's something that, if you see a basic example of plotting in Python, it's probably using Matplotlib. We also have a charting API that's part of Pro, and there's a Python interface to that through arcpi.chart. And soon you'll actually be able to embed those Pro charts directly into notebooks. So, okay, I mentioned NumPy already. What is NumPy and how does it integrate with the rest of ArcGIS? It's just an n-dimensional array structure that is a native data type of Python. So And some languages actually have this as a core data type, but in the case of Python, after some back and forth, they settled on this Numpy extension package, but it's extremely widely used. So this isn't just specific to spatial data, but though it certainly can store spatial data, it's used for everything from images to gene sequences, any kind of structure that can be represented in a multidimensional or sparse matrix can be represented in Numpy arrays. So ArcGIS gives you access to interoperate on raster table feature data with Numpy. There's a section in the help documentation you can look at. It's all in memory, so if you need to work with really large data sets, you may need to do some chunking to break things down into blocks. If you just need to work with feature data, you may be better served by ArcGIS's SEDF because that provides a high-level interface to feature data, and it's much simpler to work with than working directly with Numpy itself. So if you do use Numpy, here are some of the geoprocessing tools that let you work with it. So you're getting really fine-grained, low-level access here. You're able to take, individual cells out of rasters or individual features and break down the columns, set the data types. You can do things very quickly with Numpy. It's just a little bit more bookkeeping because you're working with a lower level interface. And the idea here is that you could take any data that you can use in ArcGIS, convert it into Numpy arrays, and then the rest of the Python ecosystem is very compatible with Numpy arrays. Almost everything knows how to read Numpy arrays. And then at the end, obviously convert that back into native data types in ArcGIS that you could use. Okay, so I mentioned SciPy. SciPy is also the name of a particular package, so it does all these different things. It can do all kinds of interesting transformations on data. It has a lot of capabilities in linear algebra for doing some kinds of statistics. I'll just show you a quick example of what that looks like. Here's an example using benthic terrain modeler, a tool built for the marine community, but it really works with any kind of raster data. And the idea here is to try to find certain kinds of patterns that indicate different morphology types in the ocean floor. So one thing we could do is just use a basic ND image to perform multi-scale analysis. We also use things like SciPy stats to compute some statistical forms that aren't present directly in ArcGIS. So here's just doing some basic thing. We're using matplotlib. We're going to do some charting, and we're going to start by doing this raster Numpy array. So we're going to get a raw Numpy array, and we're only going to pull out the upper left-hand corner of the raster, a 200 by 200 pixel block. So we're going to do that, but we're actually going to do this over a range of different sizes, and we're going to run a median filter over this size. So this is like a focal operator, right? But we can do this pretty simply here, and we can actually interactively plot that result. So there's some cases where you might want something like this. This is a nice way of just quickly getting a visualization of what scales certain kinds of features in the terrain might be appearing at. So here's what that looks like. So up here we have data pretty close to the native data resolution, and as we resample, we can see that some of these features, finer grain features, actually get smoothed entirely out until we get just kind of general gradient going in one direction across this area. Okay, so I mentioned pandas already. Pandas is something that's probably worth learning if you haven't heard of it already. It grew out of the existing R implementation of data frames. The original author, Wes McKinney, said, hey, I really want that, but I want it in Python. And it brings a really robust data analysis workflow to Python. So data frames, they seem like spreadsheets in some ways, but they actually provide a lot of really rich capability. They let you do things that basically, they give you a little domain-specific language for working with data, working with it quickly, and in many cases they can actually replace what otherwise would be uses of SQL. Nothing wrong with SQL, of course, but this gives you a nice rich way of interactively doing manipulation on data locally and doing some pretty complicated transformations that those transformations are very difficult to do just with SQL alone. I mentioned already that we're doing things to enable spatial data frames, so you can use this you can use this SEDF representation and get access to an underlying pandas representation, which also has geometries and knows how to do things like write it out to a feature class. Okay, another area that I wanted to mention is that we're doing a lot to improve ArcPi itself as well. And this is just a smattering of improvements I wanted to give you a sense of. They're not specific to the broader Python ecosystem, but they're worth knowing about so that you can know, okay, what's happening in ArcPi? What can I be taking advantage of that I maybe don't have available to me today in my code? So ArcPi metadata, if you need to do any kind of metadata transformation or you work with metadata, check that out. It's a new module. You may have saw in the plenary there was a demonstration of using the new NAX Network Analyst X package. So it's a much richer way of working with network data sets, and it's much simpler if you've previously used just NA. Raster cell iterators are they're kind of a big deal. It's a little funny because they they bring back to mind things like DoCell from grid days. But the idea here is that you can do some really great per cell raster analysis without having to do any data copying using Numpy. So it's a much simpler way of doing those kinds of calculations you might have done previously with Numpy, and it's very fast as well. So it's a really nice way of improving working with raster data at a fine grain in Python. And finally, set parameter symbology. This really lets you do interesting things where if you make a tool, you can use this set parameter symbology to do things like trigger charts and pop-ups that are generated on the fly based on the results that are coming out of your tool. So this is basically the same kinds of things that you might see in some of the more sophisticated tools, GP tools that we provide. And now you basically have access to those exact same methods that we use internally. We also are adding rich representations for data that ArcPi has. So there's already geometries, rasters, there's a few others that have these rich representations. We're going to be continuing to add these. So the idea here is you use notebooks, you get these nice rich representations, and maybe you don't have to spend quite so much time doing things like describe and trying to figure out what's inside of something if you're in a notebook context. Okay, so that's kind of what's in the box, what's going on with ArcPi. What about the broader integration story? So, what do we have beyond that? Well, one way you could look at this is what kind of code are you interested in? What kind of code are you interested in running? So, if we look here, we're kind of starting out with the most specific code that you have to do the most work for. You bringing your own code, right? This is like when you want to write code from first principles. You're going to be, using very little in terms of libraries. You're going to be really working on something from scratch. And there's times where this is great. This is a great way of, especially building up mental models of how something works, giving you a deeper understanding of what's going on a technical basis. There's times where that's exactly the approach you want to do. On the opposite end of the spectrum, you have things that we build, right? That's the 1600 geoprocessing tools and all the stuff that we do, all the interfaces you can get to through ArcPi and the ArcGIS API for Python. And those are well documented. They're often very stable. They're robust. They've been tested. There's a lot going for them. But there's lots of things that don't fall into those two relatively extreme camps. There's a lot of domain-specific tools. I mentioned Bentic Train Modeler. There's many different domain-specific tools that are often aware of ArcGIS and use ArcGIS, but they're built around specific kinds of workflows. And it's worth looking if there's anything in the area for you or some problem that you're interested in. And then, of course, there's the really broad set of libraries that exist that are more general purpose, that are often to do with Python. And it's always kind of worth thinking about, like, which parts of this are you pulling things in from, and how long do I have to worry about this code needing to live? If you write your own code from scratch, that's great. It may mean that a few years from now it's hard to read. It may mean it's easy to read. You may have to support bugs. Other people might use it. If you use existing libraries, you have to worry about, is it supported going forward? There's all these kinds of trade-offs. One way you can tackle this is this idea of stack minimization. And the idea there is that you're just really trying to focus on the things that you have specialized expertise around and not spend too much time on things that are really different than the problem you're actually interested in solving. So, for example, if you had something where you needed to talk to web services, you're probably not really excited to think about, HTTP 1.2 versus HTTP 2 and gzip content and dealing with, error response codes. You're probably just interested in getting the results out of the service and handling some exceptions and doing some work around that. So, in that case, you'd be well served by a library like Requests, which knows how to do all of those things and deal with authentication and other things for you. And, maybe it doesn't work perfectly, but there's a broad ecosystem of people who work with that. So getting questions answered, even just on things like Stack Overflow, are going to be much simpler than if you just try to roll your own code, even using the batteries included parts of Python. There's other times where really the problem you're working on does require you to work on your own code from scratch. But I encourage you to think about when you're tackling something new or something that's going to be more than just a couple pages of code. Where does this fit, and is it worth me pulling in libraries for doing this or keeping my dependencies minimum for this particular problem? And what can I leverage that obviously that Esri's already provided, or that things that are available to me simply that I know will work in the future? Okay, and now I'm going to hand it off to Kevin again to show you an example of an integration point using the MetPI package.
For this demo, we'd like to show you that the analysis in ArcGIS Pro can be extended. So this analysis ecosystem that we've been talking about is extensible. One of the powers of working with an ecosystem is the fact that it can be extended. And one of the powers of working within a Python ecosystem is that you can leverage this large collection of Python modules that the whole community has created, so that you're not reinventing the wheel each time. There's a large collection of libraries out there that you can bring directly into this analysis ecosystem to make your work more efficient. I'd like to show you one module that is specific to analysis within the meteorological community. This is called MetPI, a Python library designed specifically for meteorological visualizations and analyses. I'll do this slightly different from the way that we did demo number 1. I'll actually work in a Jupyter notebook that's running inside of a browser. So to get that, I'm going to go to the ArcGIS Pro group. I'm going to start a Python command, and you can see that I'm in a special environment here. As Sean indicated earlier, we have the ability to create separate conda environments, and I've done that creating this special environment where I've loaded some of these special modules like MetPI that I'm going to use for these demos. This keeps my work separate from the main environment that the ArcGIS Pro application is using. So let me go ahead and launch a Jupyter notebook. This brings up Jupyter Notebook in a familiar environment. Let me go to the demos. And let's look at this station plot. Station plots are used often in meteorological analyses, and they would be quite difficult if you had to code all of this yourself. This shows sky cover and weather symbols in a way that meteorologists are quite familiar with. And the first thing that I'll do in this notebook is make sure that my plots are going to occur in line. And these demos for MetPI are courtesy of the folks that actually created this module. These are colleagues at an organization called UCAR or NCAR, the University Consortium for Atmospheric Research. And they're expert meteorologists and very good Python programmers, and they created this module to make our work a little easier. So let me go ahead and do some housekeeping and import the various modules that I need. And in this case, one of the powers of this package is I can go and get some predefined data. So I've simply read those CSV files. Do some quick transformations on the data. I'll do some quick conversions to knots so the units are a little more familiar. And I'll actually take the wind speed and direction and convert those to U and V. And then now we're finally at the payoff for this demo, which is the code which actually runs and creates those plots. Let's see what those look like. Okay, and now we have familiar station plots. And you can see that these are indicating both wind speed and wind direction. From a programming point of view, personally, I would have wanted to have created this myself. I can simply leverage one of the powerful packages out there for meteorological analysis, and then I can move on with the rest of my data science workflow. So that's just a quick introduction to the power of extending the platform with additional modules.
Another interesting package that is doing really interesting work with massive data is Dask. And the idea here is that Dask can actually take a problem and figure out where it can break it up. And then when it figures that out, it can do things like parallelization locally. So you can imagine that you figure out this computational structure, and then you break it up where you feed off different pieces to the CPU. Of course, that only works as if you're not memory or I/O bound, but if you're CPU bound, that's a great approach. But you also might even have an architecture where those nodes are not running locally. They might be being passed through an SSH client, or they might be running somewhere in the cloud or something like that. So it's kind of a cool library. It's being used by lots of interesting things. And we actually have a demo of that, and also a demo to kind of show you these different pieces fitting together.
In this third demo, we'd like to talk about an important component of data science. The fact that data science, by definition, is big. So one of the benefits of working within an analysis ecosystem is we not only permit the ecosystem not only allows you to extend the analytics capabilities, but it also extends the performance and scalability of your analytics. In this third demo today, I'd like to show you a package called Dask. This is a package that extends your existing workflows so that they're scalable. Dask is a Python module that is installed via Conda into the Pro Analysis ecosystem, and Dask extends Numpy workflows and makes them scale. Dask extends pandas workflows and helps those scale. And the benefits of this is the fact that you don't need to learn a whole new system. You can use Dask to extend and scale what you already know with your NumPy and your pandas workflows. Let me show you what that would look like. So I'm just going to open this Dask notebook. Let's start with doing a little bit of housekeeping and look at the demo data that we're going to use for this. I have a fairly large collection of CSV files on disk. And what I normally would do with Pandas is I would read those files one at a time. Pandas has a very nice CSV reader, and I can just look at the headers of that and see that I've got some names and an XY coordinate and an ID for each of these people. With Dask, it extends pandas, extends NumPy, and has a lot of utility functions. So in this instance, Dask gives me the ability to read that entire directory of CSV files at one time. So it read those 30 CSV files in about 50 milliseconds. That's pretty good. So Dask actually extends pandas, so I don't need to learn a whole new syntax. I can see here that I've got the familiar group by syntax from pandas, but I'm doing that against a Dask data frame. And we'll summarize each of those. That took about 2.5 seconds. That's not too bad. And Dask gives me the ability to also export to a wide variety of formats. In this case, I'm exporting to the Parquet format, which is an open source file format for Hadoop. And let's just see if we can read that back in. And in fact, we can. Took only about 26 milliseconds to read all of that data once it was serialized out to a very efficient file format of Parquet. Well, let's look to see how Dask can actually extend Numpy. Let's just do a quick operation here of creating a 10 by 10 array of random numbers and taking the mean of those numbers. Certainly something NumPy is capable of doing. Let's see how much time that takes. About 9 seconds. So let's see, what would that look like on a 100K by 100K array? And in fact, I got the error message that I expected. Numpy, because it uses a memory-bound data structure, it can't hold that array of 100K by 100K in memory. So it realizes that, and rather than crashing my machine, it gives me a memory error. Let's now try it with Dask. Here I've imported Dask, and I'm creating a Dask array with a chunk size of 1,000. This will be important later on. It was smart enough to say that my chunk size was small, and it adjusted that automatically. And you can see that Dask is not having a problem with this. It is indeed going to create this array that is 100K by 100K and automatically taking care of the memory management in order to do that. To us, it appears like a continuous array, but Dask is managing spooling that array to disk in the background. This will take a few minutes, so I'm going to interrupt the kernel here so that we don't waste our valuable time today just waiting for an array to be created. But one of the other benefits of using Dask, since this is a big task, I might want to display a progress bar to the user. Let's look to see what that would look like. And in fact, you can see that I'm getting some progress information here, some feedback to the user that Dask is doing things in the background. And in the full spirit of transparency, I'm not creating that 100,000 by 100,000K array here. So Dask accomplishes this by very efficient task management. Dask is aware of which tasks can be run together and which tasks have interdependencies. It does that by creating task graphs in the background. And if you're curious to find out what Dask is doing in the background, they give you the ability to see those task arrays. Let's see what that would look like. And indeed, it does show you how it organized the creation of that array. So you can see that Dask extends pandas and Dask extends Numpy. Dask can also extend the scikit-learn library so that you can scale up your machine learning workflows. So it's a very powerful library that I encourage you to dive into. It's got a fairly shallow learning curve. As you can see, I'm just extending workflows in Numpy and pandas that I already know. It's a pretty powerful platform. Back to you, Sean.
Okay, so I've already kind of talked about some of the integration, the integration points. We mentioned Anaconda. It's really an important part of this. It lets us do things that we wouldn't otherwise be able to do. We use it for environment management. It is what puts together our whole Python distribution. It's also what's used for all the Docker runtimes. So if you're using notebooks in the hosted notebooks in enterprise, then you can actually build custom containers. And the way that you usually would want to construct that collection of packages is using Conda. We also host a number of libraries that we've built. Sometimes these are just simple repackagings or changes in the dependencies to packages. Sometimes these are more deep integrations, things like the lurk package for error adjusted rasters. This will get you a really simple way of installing these into your local system. So we mentioned ArcPi and the ArcGIS API for Python. We already talked about Numpy and pandas integration. There's also integration with things like PyTorch. So if you use the ArcGIS Learn package, it heavily is wrapping a lot of the really interesting things that are going on in PyTorch and providing you a geospatial focused lens on top of that, which is really great. Notebooks, you've seen a lot of notebooks already, and the ArcGIS bridge. So we'll talk about this a little bit more later, but we have a project to also let you extend and integrate into what's going on in the R world. All right, so a little bit has passed. So R is a statistical programming language. It has very powerful core data structures for analysis and really an unparalleled breadth of statistical routines. So in the academic communities of practice where there's a lot of use of statistics, R, it really dominates, and it's true in the biofields, in pharma, in ecology, in many different fields. Many of the people who are scientists, they might not even really consider themselves to be developers. They're statisticians or scientists first, and then they just happen to have to do some development to show other people what they're doing. There's really interesting things happening there, and it's part because it is really a domain-specific language. So it wouldn't be a great language to write a web page in, but if you're just doing some scientific analysis, then it has rich tools. It also is not sometimes not forgiving. It's kind of built to teach you the methods. So you do need to know something about what you're doing when you actually implement some code that uses some of the packages in R frequently. So what do we do with R? We have the R ArcGIS bridge. The package name is called ArcGIS Binding. We have a web page for it, and I'll show you a couple of the resources in an upcoming demo. But basically it lets you access any of the data you can get from the ArcGIS ecosystem. You can transform that data into native R spatial types, and then you can losslessly transform that back. So you might take some data, do some analysis using these R spatial types, and then at the end of that, you have some new results, and you want to feed that back into your local feature class, your enterprise geodatabase. So you can do all of that. You also can embed ArcPi and the Python API code using the Articulate package. So it works in RStudio. You can make tools that run in ArcGIS Pro that are calling R internally. You also can do things like make web tools, so you can use geoprocessing services, and these could even be doing things like driving a dashboard or a story map. And finally, we've added just recently the ability to use Jupyter notebooks with R, and this includes things like Esri leaflet. So you can conda install this package. It'll stand up a whole environment. Okay, so let's get to showing you what that looks like with an R demo.
In our last demo today, we'd like to show you how you can bring the power of ArcGIS Pro and the power of notebooks together. I'm back in our familiar ArcGIS Pro application, and what we're looking at here is a data set that's showing conflicts. This is the ACLED data set, and we're looking at two different types of conflicts: violent demonstrations and peaceful demonstrations. So we want to see if these things are occurring together or where they might be occurring together. Let's look at how we might do that in a notebook. So let's do some quick housekeeping and import our libraries that we need. We want to make sure that we can overwrite the output of this analysis and run it multiple times. Now in this notebook, what I'm doing is pointing to my input analysis layer. And notice here that I don't have a long path name. I'm actually referring here inside of the notebook to something that exists within Pro's content pane. So I don't have to worry about a lot of path management. I can let Pro do that for me. I can preview my data sets in ArcGIS Pro, which is very good about projecting data and displaying it and giving me lots of very quick options for visualizing that. So I wouldn't be spending my time as a Python programmer putting together a lot of maps within my notebook in order to do that data exploration. Let Pro do the things that it's powerful at. Let notebooks do the things that, that they're powerful at. So I want to do some initial exploration. The first step to any good statistical analysis is to explore your data. And I'm going to do that with pandas and a graphing application called Seaborn. So let me go ahead and convert that feature class to a pandas data frame. And I can see that I've got the data frame here. I'm going to use pandas indexing power to get that date. And then I'm going to do something in the notebook that I wouldn't have been able to do in ArcGIS Pro. While Pro has a lot of very powerful graphing and charting capabilities, it doesn't yet have a violin chart. And as part of this analysis, when I looked at the map, I can actually see that there appears to be a lot of conflicts around New Delhi, the capital. And perhaps these are peaceful political protests centered around the capital. And I want to explore that before I go and run my analysis. And one way to do that is with violin charts. And I can do that with Seaborn's violin charts. Here, I've chosen to use the power of Seaborn, a Python library, to map the distance from the state capital by the different protest type and see if that's changed across years. And we can see that indeed there are more protests as we get closer to the capital. That might encourage me to run a different analysis in that area or to separate those out and run a different analysis. Now that I've done some exploration, inside of my notebook, I can run a tool called collocation analysis. This tells me whether or not two different types of categorical variables are significantly located within a particular distance of each other. And again, I didn't type all of this syntax. I simply went over to my catalog, to my history, and I right-clicked and did copy Python snippet and pasted it into the notebook. It saves a lot of typing. When I run this, I actually created the output here, and I get the messages back out. One of the nice benefits of doing this in a notebook is that I can embed markdown cells, which remind me and reminds folks that I've shared this demonstration with exactly what this tool is doing. So this is just documentation directly out of the Esri help. I can also embed the output of my GP tool directly inside of my notebook. And indeed, we can see in areas around New Delhi here, this dark brown color, which indicates that peaceful protests and violent protests are significantly co-located in those regions, much more around New Delhi. So that violin chart really advanced and informed my analyses. We can take the charts that are produced from Pro and I can look at them here. Now the power of this is that I can go in now to that data set that we used to run the analysis. I could open the attribute table, or from the map itself, I could simply select just those events that occurred in the New Delhi area. I can go back to my notebook now, and when I rerun these cells, it will now actually only use those selected features that were on the map. So you can see in this demo that there's very nice interaction between the contents pane, between the map, and the notebooks themselves. So it allows ArcGIS Pro to do the things that it's very powerful at. It allows notebooks to do the things that they're very good at. So I think the mixture of both of those really do indeed create a very powerful spatial data science workbook. Back to you, Sean.
All right, so what's coming next? What's in the future? So the deep learning story is continuing to evolve. It's a very nuanced space. There's a lot of different pieces to make this work well. There's obviously already tools you can use today that do really interesting things. There's sometimes a gap between what those specific tools can do in terms of, like, say, working with CHIPS data and what's happening more broadly in the deep learning research space. So we're always looking at what we can do to bridge that gap and give people things that don't kind of fall on either a pure research project side or a purely packaged up tool that does a very specific thing. But that will continue improving this next year. There's rich representations for many more objects coming. We already mentioned that there's a few. There's more coming in arcpi, and this will just make that experience of using notebooks both in Pro but also in the hosted and online context much nicer than it has been. And online notebooks are coming by UC this year. Also, we're working on getting arcpi available in external Conda environments. So the idea here is that you could have a Conda environment that a data scientist stood up, and as long as Pro's on their machine, it can be detected. They can have their dependencies totally decoupled from the ones that Pro itself has. So this is what that might look like. You might use Anaconda Navigator if you're not using our software and you install arcpi. And then it would make sure the core dependencies for arcpi are satisfied, but you're not concerned about modifying anything that the Pro application itself is using. Okay, so resources. We have a lot of resources. I'm not going to go through all of these here, but know that they're here in these slides. You can download them afterward. We've tried to provide you a very broad swath of interesting things that we found that have helped us in the work that we're doing. So from learning to GIS-focused activities to some courses that are available to books that are available, a lot of really great resources that you can take advantage of. Okay, so just to wrap it out, thanks so much for listening, and thank you to our teams that we work with on this project, and really thank you to all the open source projects that really drive these things. Esri's, we're part of this story, but we're really only a small part of this broad ecosystem and community. So, if you find things that are interesting to you, get involved. The community is great, and there's a lot of great things you can learn just by interacting with other people from this community.